Lesson 2-5, Solving Systems of Inequalities. This is on page 105 in your book, 105. There we go. All right, so solving systems of inequalities in two variables. So you guys know what an inequality is. It's where you have this inequality sign, so it can be less than, greater than, like less than or equal to, greater than or equal to, maybe. Right. And what does that look like in two dimensions? Say if you have a y and an x-axis going on, right? Well, here, if you look at this example here, you got y is less than or equal to 4x minus 3. Now, if I made that an equation, like y equals 4x minus 3, has an intercept at -3 and a slope of up 4 over 1, that's this line right here, solid line. Now, y can be less than that. That's anything underneath the graph, which looks like both this yellow and green region right here. You can also pick a test point. So for example, right here, it's going to be the point 3 comma 0. That should work, right? So if I plug in 3 for x and 0 for y, is that a true statement? 4 times 3 is 12. 12 minus 3 is 9. Is 9 greater than 0? Yeah, absolutely. So that checks out. Actually, any point in this region would work. And then what about this other inequality? Negative 2y is greater than x. That one I'm going to rewrite. So negative 2y strictly greater than x. Could I divide both sides by negative 2? I get me y. Oh, and then if you divide by a negative, what happens to the inequality sign? It flips the other way. So this is negative 1 half x. Okay. If I thought about this being like an equation, this like y equals mx plus b sorted, right? It would go through the origin and have a slope of down 1 over 2. Right, so that, hey, that's this one right here. It goes through the origin down 1 over 2. And notice it's dashed. It's a dashed line. The other one was solid. This one's dashed. That's because it's strictly greater than, or in this case, that's strictly less than. Right, so let's see, what could be underneath that line? That looks like this blue and this green region could both work. Let me pick a test point. Let's say, how about 0 comma negative 1 right there? So if I plug in 0 for x and negative 1 for y, does that make a true statement? So 0 x is here, right? Negative 1 would be positive. Is 2 greater than 0? Yeah, absolutely. And so that would any point that would work. Now, what about the combination of these two? Now, if I was talking about the union of these two inequalities, like if this statement could be true or the statement could be true, then the answer would be all three of these regions, the yellow, the green, and blue. If I'm talking about the intersection, if they both have to simultaneously be true, one's true and the other's true, then only this green section right here works. That satisfies both of these inequalities. Okay? And then you can pick test points just like I was doing. So anything that's green would region would satisfy both of these. Right. So we were just looking at this right here. So back to these terms, we got the system of inequalities. Right? The feasible region is, in this case, they're talking about the intersection of the graphs. So they would be talking about them both being true. Um, uh, the okay. If it's bounded, it creates like an actual definite area. Like for example, on the next page, you guys see this little triangle right in the middle. That would be called bounded. If it's unbounded, then it could be a region that's open and just goes on forever. For example, this green section down here could go on infinitely down and to the right. So that would be unbounded. All right. So we've got that established. Let's check out. Oh, yeah, let's check out this little triangle right here. All right, so this bounded region. Now this one they give you three inequalities. Ooh, three inequalities. Right here. I can just point out exactly what's what. Right, so boost this up here. Okay. So y strictly less than negative 4/3 x plus 5. Yeah. So y intercept at 5. That's right here. Right. Down 4 over 3 would be the slope. That's this dash line going right here. This diagonal dash line. Okay. It is dashed because it's y is strictly less than. And so anything underneath that line, so anything down here would satisfy that first inequality. The second inequality, y is greater than or equal to x minus 2. X minus 2, that's so y intercept negative 2, and then has a slope of up 1 over 1. That's the solid line right here. And it's solid because y can be greater than or equal to. Okay. And then the greater than part refers to anything above it. Okay. So on that line or above it. Okay. And then finally, x is strictly greater than 1. Now, if you see x something in a number and there's no y value, that refers to a vertical line, like just some x value. And that would be this vertical dash line right here. And of course, it's dashed because strictly greater than. Right? So how about anything to the right of 1? Like if x is 2, that works. If x is 3, if x is 4, if x is a million, that works. Okay. If x is 0, negative 1, negative 2, that would be a false statement, so that would not work. And so you put those three together. If you say, what's the intersection of these three conditions, it would create exactly that blue triangle right in the middle. Something like that. All right, so that's right there. Okay. So that's like some pure math examples. Let's take this to a word puzzle. So pretty exciting right here. Use systems of inequalities. A Niagara Falls boat tour company charges $19.50 for adult tickets and $11 for children ticket. Each boat has a capacity of 600 passengers, which includes 8 crew members. Now, I'm going to interpret that as 592 tickets they can sell, and then they have to have the additional space for 8 crew members. Right? I guess right, so just pick an interpretation to go with it. Suppose the company's operating cost for the boat tour is $2,750. Right? So, all right, so maybe in terms of like paying crew members and buying the fuel and for the boat, right? Write and graph a system of inequalities to represent the situation so that the company will make a profit on each tour because they do have to sell so many tickets. That's probably what they're thinking. It's like, okay, well, how many adult and children tickets do we have to sell so we can at least cover our costs and ideally turn a profit? Right, then identify some viable solutions. Right, like remember, so if you pick a point and maybe you could work. Right? So I bet if they sell like hundreds of tickets. Oh, okay, let's try it. How can we turn these into equations? Okay. So I know that since well 600 minus 8, I'll call that 592. So they have sort of like 592 tickets to sell. I'm going to define X as being the number of adult tickets. Okay. And let's have Y be defined as the number of children tickets. Children tickets. Okay. Right. And from there, I already know that there's so much space in the boat, right? They can only go up to 592. So right away I can say X plus Y. Okay? At best, it could equal 592, but maybe they don't actually even sell that many, right? It couldn't be more than 592, but it could be less than, or it could be fewer than. So I'll say less than or equal to 592. Right? And there's one equation right there. There's one condition. If I add up all the tickets, it can only go up to 592. So we have an inequality. Okay? Then we're really interested in turning this type. Well, we make a profit. You want to get at least this much money out of selling these tickets. So I'll do $19.50 for an adult ticket. So if I do $19.50 per ticket times the number of adult tickets, right, that would represent some number of dollars plus $11 per child ticket times the number of child tickets. Again, that the number of tickets as a unit cancels, and that's some number of dollars. Okay? I would like that to be at least $2,750. So it could be greater. I mean, that would be great. It could also be equal. That would be fine too. $2,750. This right here is my system of equations, or sorry, system of inequalities. That's what I should have said. System of inequalities. Right? Right. So I'm gonna now I can turn this into a graph and map this out and see what does this actually look like. And so let's go y-axis is the children's tickets, x-axis is number of adult tickets. So I got x-axis this way, y-axis this way. Okay, we can start at 0, 0, right? Right. And then what? Well, actually, maybe I should rearrange these expressions. So if I rearrange the top one, get y in terms of x, so I can put it sort of like slope-intercept form. Would that be y is less than or equal to negative x plus 592? Okay, and this other one, I could subtract over 1950. Okay, and then after the fact, I would have to divide by 11. So here, I'll do both those steps right here just to keep this clean looking on the page. So negative 19.50, so with the x attached, then divide that all by 11 after the fact. This is going to be y is greater than or equal to negative. Okay, that's a look at decimal, right? Negative 1.7727x. And then what's 2750 also divided by that 11 originally would be say plus 250. Right. So here's the same system. It's the exact same system. It's just form like slope intercept form. So, all right, what are these graphs about these? Right? And so I could go to get some numbers on this graph here. Let's put 592 here. In fact, you could sell 592 tickets the other way, right? 592, 592, right? Okay. Like if you sell them all to adults, this would be this point right here. If you sell them all to children, there are no adults on board. There's Lord of the Flies. That would be this point right here. Okay. And then this equation, I'll put the pinky to mark this out. Would be this right here. Okay. So if they sell all boat available spaces, it's going to land somewhere on that line. Yeah, all adults would be right here. All children would be right here. If it's like half and half, it'd be right here. If it's like mostly adults and a few children, it might be here. If it's a few adults and a lot of children, it'd be over here. So, okay, that would be like a perfect sell. That's this equation. Okay, now what about this bottom one here? Well, I know 250 would be the y-intercept. That's not quite halfway up there. So maybe approximately right here could be 250. I wonder what sort of like the x-intercept would be. Well, I know the y value for the x-intercept is always zero. So let me plug in zero for y and see what does that come out to. So if I plug in zero right here, or sorry, zero for this y, zero, subtract off 250 and then divide by this. So basically it's 250 divided by 1.7727. It comes out to 141.02. 141.02. Well, if I put that, that's probably right about, see, it goes up to here. It's probably right about here. It's just kind of ballparking. Okay. I'm going to put 141. Okay. Now, if they sell 141 tickets, all to adults in this case, okay, 141 tickets to adults and to no children, okay, they don't quite turn a profit. They're a tiny, tiny, tiny bit in the red, right? Because they need to sell like 0.02 tickets more. Of course, they can only sell probably a whole number of tickets, right? And what that leads me to think is that they really have to sell more than some combination between these. Right? So if there's like a line here, this is really 1 point. If it was 141.02, I could make a solid line. But if I go to 141, I'm actually going to dash this line, right? Because they really have to sell like more than that. So it has to be more than this dash line to turn a profit, but it has to be less than the solid, like fewer than the solid line, because well, that's what the inequality also said, because there's only so much boat space. So really the space that I'm interested in is anywhere in here. They would both be turning a profit and also they have enough boat space. There it is. So that would be the solution to that inequality, this whole pasteurization right here. Right? And oh hey, look at that. Right, that's exactly right there back two. Right, so got here, what we're getting here, looks like the same thing. That's it. Totally it. Okay. Um ah you know what? Before I move on, is to check some viable solutions. And they give you 5 possibilities. So I'll pick 3 of these and test them out. Let's say 60 adults, 100 children. Would that be viable for what they're going for? Okay. 60 adults would be right about here, and 100 children is right about here. That'd be there's 60 comma 100. That looks like they're not going to turn a profit. Like they have boat space, but they're just not going to turn a profit. I think. Let me see. I can try this out because I know it's $1950 adult ticket, and we're doing 60 adults. Oops, that's 1950. Okay. Plus, and it was $11 per child ticket times 100 child tickets. Okay. I bet this number is going to come out to less than the 2750 they need to turn a profit. Yeah, it is 2270. That's less than 2750. Okay, so they're definitely not turning a profit in this black point, which I didn't think so. Okay. How about 415 adults, 200 children? 415 adults would be like kind of here, and 200 children. Okay, that's somewhere about here-ish. What does that add up to? 615? Oh, no, that would not work. Because look at this, 415, 200. 415, 200. So probably right about here, actually. Okay. I don't think they even have boat space for that. If you add those up, 415 plus 200, yeah, 615 tickets altogether, but they only have like 592 or 600 boat spaces. Yeah, so they don't even have space on the boat. So that would also be not viable. So I checked the first one, I checked the third one. Those are both not viable. How about 550 adults, no children? Would that be viable? Well, that would be right here. Right. Yeah, so they have boat space for that. 550 adults, no children. And just glancing at my graph, that looks like it's definitely profitable, but I can check for sure by checking on the calculator. $19.50 per adult ticket for 550 adult tickets and plus zero for the children. Yeah, $10,000. $10,000 is definitely more than 2,000. So okay, yeah, yeah, that would be viable. So I checked three of these. Okay, two of them I checked didn't work, and then this last one checked out. It worked. Uh, Page 108. Fundraiser. The International Club raised $1,200 to buy livestock for a community in a different part of the world. Ooh. The club can buy an alpaca for $160 and a sheep for $120. The club wants to donate at least 8 animals. Determine the system of inequalities to represent the situation. Right. So, okay, they want to purchase 8 animals. It could be 8 sheep, it could be 8 alpacas, it could be like 4 and 4, it could be 3 and 5. Right? But here's the constraint, the conundrum here is they only have $1,200 to spend. So they probably wouldn't be able to afford 8 alpaca, I don't think. Right, so let's come up with a system and graph it and see what does that look like. I got looks like their x-axis is the number of alpacas, so I'll say x is the number of alpacas. I got y equals the number of sheep. Okay? And the first condition here is they like to sell, it says at least 8 animals, so it could be 9, it could be 10, it could be 11, right? So as many, right? So x plus y, the alpacas plus the sheep, right, should be greater than or equal to 8. Right? So that's one condition they're looking for. Okay? The other condition is if they're doing let's see, $160 per alpaca times the number of alpacas, plus $120 per sheep times the number of sheep. Okay. Well, that's got to be less than or equal to $1,200 because that's all their budget can afford. So this is your system right here. Here's your system. Okay. Now this looks like standard form, doesn't it? Standard form. Right. Maybe I could rearrange this and put this in slope intercept. So subtract off the x, number of alpacas. So the y is greater than or equal to negative x plus 8. That's just that right there. And then this one I can rearrange. Okay. Subtract off 160x and divide both sides by 120. So that the y is less than or equal to, now what's 160 over 120 after I subtract it. So negative 4/3, it looks like. Negative 4/3 x. And then what's 1,200 over 1? Oh, that should be 10. Yeah, 10. There you go. So plus 10. All right. So there's the exact same system. So let's say it's the same system, except now it's in slope intercept form, right? Which I think is probably easier to graph. Right. Okay, I think you got enough space down here. I can take this graph right here. All right, so we got two axes. X is alpacas, right? And I got a y-axis, which is the number of sheep. Okay. Uh, right. So greater than or equal to, okay, that's it. Okay. If I have at least 10 on the vertical axis, maybe I'll go how this okay, let's go 5, 10, 15, then 5, 10, 15. That should be plenty of space. 0, 5, 10, 15, 0, 5, 10, 15. Okay. Right, where's your pinky get negative x plus 8? So say negative x plus 8. So plus 8 would be right here is 8. Okay. And then negative, so it has a slope of down 1/1. That would also bring you to 8 over here, right? So if x is 0, y is 8. If y is 0, x is 8. Okay, so that would be this line. Okay. And it has to be greater than or equal to that, because so again, they could sell 4 and 4, or sorry, send. They could send 4 and 4, they could do 5 and 3, they could do 3 and 5, you could do 8 and 0. Okay. Any of those combinations would land on that line. Okay. It's more than that, so something above that. But they also have this budget constraint. So plus 10, that would be like right here. And then down 4/3. Well, where would the x-intercept be? If I plug in 0 for y and add this over, so it's whatever 10 times 3/4 is, that's like 7.5. Okay, so if I follow this line down with the slope, it's going to land at 7.5. Yeah, okay, so 7.5, just like right here. Okay, so that would look like this. Zoop. Okay, so maybe this should go on with a different color. Okay, so if this is, let's say, pink right here, maybe I'll change this to blue. How about that? Change this to blue. So blue is budget constraint. Blue budget constraint. There you go. Easier to see. Okay. So they want to sell at least as many as the pink line, so more than the pink line. So if they could send 100 animals, I bet they would send 100 animals if they could. But they're constrained by this blue constraint. So the region that works, the viable region, would be this little skinny wedge right here. Okay, so that's the feasible region. Yeah. Double check their terminology. Yeah, the feasible region, that's what they're calling it. So the points would be viable. And then they provide combinations of animals and they want you to test and see which points are viable. Right, so yeah, let's do the same thing. Let's test three of these. Maybe I'll do A, C, and E. So A, could they send 0 alpacas and 10 sheep? Yes, they could. That would max out their budget. It would spend all their budget on sheep, and it would be more than 8 animals. So that totally works, right? We skip down to 3 alpacas, 6 sheep. But that's pretty close. 3, 6. It's pretty close to their budget constraint. So I'll test this one out. So if I do 3 alpacas times, here, let's spell it out over here. 3 alpacas, uh, how much is an alpaca? $160. Right, plus, um, they said 6 sheep at $120 a sheep. Right. So 3 times 160 plus 6 times 120. Okay. That comes out to $1,200, which is exactly their budget constraint. So yeah, the point 3, 6 does work. Right. It is also viable. So 3, 6 works, just like in the beginning. 0, 10 works. Right. So A and C both work. A and C both work. They max out the budget. That's right. How about option E? 8 alpacas, 0 sheep. Well, I can see right away from my graph that uh, that's going to be beyond their budget, right? It's just outside their budget range. They don't have enough money to buy 8 alpacas. I can show that here. So it's 8 alpacas times 160. No, sorry. Yeah, $160 per alpaca. 8 times 160. It's got to be more than 1,200 because I'll push it on the graph. It is. It's $1,280. So they're just short on funds to do that. So option E would not be viable. Right? That would be this point right here, and that's outside the constraint. So there you go. You can test the other two if you like. We're gonna move on to these. So I have some pure math examples, right, and then we have a word puzzle here, right, and then I'll do a couple of word puzzles here, and that will be a wrap on here on this one. Let's see, lesson. Right, number one, solve each system of inequalities. Number one. Right, so we got x minus y is less than or equal to 2, and x plus 2y is greater than or equal to 1. Right? So there's my system. Right, it looks like standard form. Right, so just like usual, I'm going to change this to slope intercept. So I'll rearrange this one, I'll rearrange this one, put in slope intercept. First, she's going to be a couple of steps. Here, well, I'll break it down to 2 steps. Like it's subtract over x. So negative y is less than or equal to negative x, and then plus 2. And this one turns into 2y greater than or equal to negative x plus 1. Okay. But then I'm going to rearrange this one more time. Rearrange. Okay. So I'm going to divide this top one, divide those sides by -1. So that'd be y. And guess what happens to the inequality? Whoop, swaps places, right? Which is direction. This is positive x minus 2. And this bottom line, I can divide everything by 2. Okay. And so the inequality would stay the same. And this would be -1/2 x plus 1/2. Maybe like that, right? Yeah, right, that looks right. Okay. So this is my system, the same system and slope intercept form, slope intercept form. Right. Yeah, we can plot that down on the graph. So let's do okay. X dot Y. Okay. Oops, so that's it goes negative, doesn't it? Yeah. All right. Let's just start over. Okay, I got space over here. Just over here then. Let's put X axis over here, Y axis here. Let's go. Let's see. -1, -2. Let's go 1. Let's go 2. And then 1, 2, 3. All right. Let's see if I'm able to fit it in this space. I think so. Okay. So X minus 2. Right, so it's y-intercept at -2 has a slope of up 1 over 1. Okay, now it could be greater than or equal to this line right here. So it could be on this line or above this line. So on or above this line. So that's my first condition. My second condition, say -1/2 x plus 1/2. So 1/2 plus 1/2 is right here. And then down 1 over 2 would look like this. Right? So it has to be above that line. Right? So it has to be above both of these. So I think the answer would be this right here. So this unbounded region, because it could go like up forever, right? Okay. So here, I'll pick a test point. So looks like the point 1 comma 1 should work. Okay, here's the point right here, 1 comma 1. Okay. That should satisfy both conditions like, as an intersection. So if I plug in 1 for x and 1 for y, I should get two true statements. Okay. Here, I'll need to go back to the original version. Okay. So 1 minus 1, which is 0. Is 0 less than or equal to 2? Yeah, it totally is. Ding! How about this other one? But again, I'm plugging in 1 for each of x and y. 1 plus 2 times 1, which is 2. So 1 plus 2 is 3. Is 3 greater than or equal to 1? Yes, it is. Bing! So, yeah, so this test point right here passed both tests. So we're good. All right. Next one, number 4. 4. I've got y is strictly less than 1/3 x plus 2. And also, y is strictly less than -2x plus 1. Right? Now, conveniently, the system is already in slope-intercept form. And so I can just graph it straight up as it is. And so they both got a positive intercept. One has a positive slope, one has a negative slope. And so let's go x here, let's go y here. So, put this on the screen. Okay, got number 4 up there, got the graph. Okay, okay. All right, so let's go 1, 2, 3. Let's go 1, 2, 3. All right, let's see how this plays out. So 1/3 x plus 2. Oh, okay. Well, it's all right. I'll make this work. Okay, so less than, now, okay, so I'm at that plus 2 right here. Okay, but it is up 1 over 3. So I got a point over here, right? This would be the point 3 comma 3 right here, because that would be up 1 over 3. Now, if I go back the other way, yeah, right, I made a graph too big, I think, because I would commonly be interested in knowing like what's the x-intercept. But the x-intercept, that's where y is equal to 0. Right? That would be at -6. So I'd have to go all the way to -6, which is a little bit up there. Which, you know what, I can do this. I'll stagger my paper. You like sort of tape this together. Oh, and I should not do a solve. I should do a dash line. Let's do dash because this is strictly less than right here. So I'm going to dash this. This goes all the way back to extend this axis. Keep on going left, 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 left. Right, so 1, 2, 3, 4, 5, 6. So -6 is way back here. Yeah, that aligns with it right there. Like -6. So like you go dash, 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 dash all the way. Okay. So strictly less than. So it could be anything underneath that line. Now, what about my other condition? -2x plus 1. So here's my plus 1 right here. Okay. And down 2 over 1, that's like down 2 over 1. So the point 1 comma -1. Okay. And this would also be a dashed line. So it would look like this. Dash, 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 dash. Like that. Okay. Now, since the intersection would be underneath both of those first, that looks like this big old area right here. So all this could be the solution. Okay. Now, at one point, the solution looks like this origin point right here, 0 comma 0. 0, 0. Okay. So plug in 0, 0, 0 for x and 0 for y to each of these statements. I should get two correct statements. Let's see if that's true. 0 here, 0 here. So 0 less than 2. Yes, it is. Ding. How about this other line? Is 0 less than, it's also 0, 1. Is 0 less than 1? Yes, it is. Ding. So this test point passed both statements. Yeah. So we shaded in the correct region. Everything's good. Okay, number 7. Ooh, system of inequalities. But ooh, now there's 3 inequalities set up. Ooh, 3. So y is greater than or equal to negative 3x plus 7. We got y is strictly greater than half x, and y is strictly less than 2, right, which would be a horizontal line, wouldn't it? Or that last one would. Okay. All right, so let's see. Okay, we got plus 7 there. There. I think this space should work. X, Y. Let's go about well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And a negative. 1, 2, 3, 4, 5. Okay. And let's see what this does for us. Right, so negative 3x plus 7. So the plus 7 is right here, my y-intercept. Okay. And then down 3 over 1, down 3 over 1, and down 3 more over 1 again, down 3 more over 1. I can keep going. Okay. And then since it's greater than or equal to, this would be a solid line. So solid line, it can be anything above this line. So like 11 to the right in this case, right? Okay. Next one, 1 half x. Now 1 half x, you can say plus 0 if you like. So it goes to the origin. Okay. And then up 1 over 2 lands on this point. Then up 1 over 2 from there, and it's over here. Okay, you can keep going. But it is strictly greater than, so this would have to be dashed. So I'm going to dash, 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 dash. Okay. So above this line, above this line. And then y is strictly less than 2. Well, that would just be a horizontal line. Oh, yeah, look at that. Dash, 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 right? So it looks like the solution is just this little bit right here. It's a little tiny triangle. Oh yeah, that's it. Okay. Now, what's a test point I can pick inside that triangle? Yeah, it's pretty small. How about 2.5 comma 1.5? That looks like it's right about there. So, okay, so cause the point 2.5 comma 1.5. That's like an XY value, right? XY. Right? I'll label as a test point. Okay? Like that point should pass all 3 of these tests. Let me see if it does. Right, so it's y, which is 1.5 right here, 1.5. Is that greater than or equal to? So got negative 3 times 2.5 plus 7 comes out to negative 1 half. Is 1.5 greater than negative 0.5? Yeah, it sure is. Sure is. So pass the first test. Ding. How about second test? Y greater than 1 half x. So 1 half of this x is 1.5 greater than 1.25? Yeah, it sure is. So pass that test too. Bing. And finally, is y less than 2? Well, my test point, the y value is 1.5. That's less than 2. Bing. So yeah, I just passed all 3 tests. So that's the answer, that little tiny triangle right there. That is it. We got next. Number 10. Number 10. Ah, let's get a new page. I got y is less than or equal to 0. So y could be negative, y could be negative or 0. X also could be negative or 0. And then also y is greater than or equal to negative x minus 1. Okay. So these are all, and well, this one will slope intercept. We can graph these. So here's my system. Okay. Let's see. Negative x minus 1. Yeah, okay. Oh, I know what it's going to look like. So let's do x here, y here, go. Negative 1, negative 1. Okay, here's 1, here's 1. Okay. Okay. All right, so I think that's all I need to be able to graph this. So y is less than or equal to 0. Well, y equals 0 would be the x-axis. So I just graphing the x-axis. X is equal to 0 would be the y-axis. So that's a line. Okay. Now, less than or equal to, less than or equal to. So I'm talking about this quadrant 3 down here. So something down here. And finally, y is greater than or equal to negative x minus 1. Well, negative x minus 1 looks like this. Okay, it is. These are all possibly equal to. Just double check. Yeah. Okay, so nothing strictly greater than anything like that. So they would all be solid lines. It has to be greater than that. So above this line, but to the left or down at the other line. Right here. So here's the solution. Okay, so there's number 10. You could make a test point like at this point right here, negative quarter, negative quarter. It should pass all 3 tests. Yeah. All right. 13 tickets. High school auditorium has 800 seats. Suppose that the drama club has a goal of making $3,400 each night of their spring play. Student tickets are $4, adult tickets are $7. Hey, this reminds me of that boat question from earlier. Write a system of inequalities per the situation, graph it, and then could the club meet its goals by selling 200 adult and 475 student tickets? All right, well, let's find out. So 13 tickets. Right, so 800, so let's call the XY system, right? So let's call X equal to student tickets, and I'll define Y as adult tickets. Okay. All right, now if I add an X plus Y, see, they only have 800 seats. So this could be equal to 800. It could also be fewer than 800. So I'll say less than or equal to 800. And so we have one inequality. Okay. Also, in terms of the prices, if it's $4 a student ticket, so $4 a student ticket times the number of student tickets, now that represents some number of dollars, plus then $7 an adult ticket times the number of adult tickets, again, some number of dollars. Okay. They would like that to be greater than or equal to $3,400. So, okay, so the top equation is in terms of number of tickets. The bottom equation is in terms of number of dollars. Okay, so there's my system. Again, this isn't standard form. Okay, so I'm going to rearrange this, put this as slope intercept. So the first one, very simply, subtract over x. So y is less than or equal to negative x plus 800, or 800 minus x if you like. And this other one, it's going to go, it's subtracted off the 4x and then divide both sides by 7. So y is greater than or equal to, now this would be negative 4 over 7, the x, and then plus, right, this one got a calculator, 3,400 divided by 7 works out to 485.71, something. With that, because this is number of tickets needed to sell. So you can't sell decimals of tickets. Or if you wanted to, you could round this to 486 and make this strictly greater than. I mean, that'd be one interpretation. Here, I'll just keep what I have and we'll run with it. Right, so this would be the same system and slope intercept form. Okay, so I'm going to graph that, or use that to graph it. Set this up. The system here. Okay, well, we got to go up to, looks like 800 on the y-axis. And, well, probably 800 on both axes, right? So each of these could max out at 800. Right, so on the y-axis and the x-axis, right, x is student tickets, y is adult tickets. Each of these could go up to 800, 800. Okay? Because that would be represented by this first inequality. That's going to just go like this. Okay. Y-intercept of 800, slope of -1. Okay. And if they sell out every single seat, then it's going to like somewhere on this line. Like if they sell all the students, that'll be this point right here. If they sell only adults, it'll be this point here. It's like half and half would be this point. Okay. But it could be anywhere along that line if they have a sold out crowd. Now this other one represents their revenue, they're trying to turn profit. So 485.71, that's more than halfway up here. Like here's 400. So 48 here, see 600, this would be 500. If it were 480 something, that's probably right up there. And then down 407. You know what I like to do? Let's label this point as 485.7 something ridiculous. Uh, I'd like to know what is the x-intercept down here. And to do that, that's where y is equal to 0. So I'll set this equal to 0, solve for this x-intercept. So let's see, subtract this at 485.71 something something like, times 7 over 4. Or so 850 basically, 850. Okay, so I know that, that's interesting. Because here could be 900, here's like 850. 850. Okay. So yeah, I see what's about to be happening. Okay. It's like these. Okay. So here's my um sort of like my tickets or seats line, and here's like uh the necessary uh sales for to turn a profit sort of. Right. It looks like if they sell all 800 tickets to just students, they're going to come up short in terms of profit, right? They're going to be at a loss because they got to be above this line, but below this line at the same time. Okay. Above the profit line, but below or equal to how's that? Right? You might even take that necessary sales and like dash it because they can't sell fractions of tickets. So it'd be totally reasonable if you wanted to just go ahead and like dash this line, like something like that. Okay. Anyway, looks like they got to sell something somewhere in there. Now they did pick one point that they wanted us to test. They said, could they do 200 adult and 475 student? Now, with that, okay, 200 adults, well, there's 400, or whoops, sorry, 200 adults, looks like right here. And then 475 students, well, here's 400, so 475 is a little more than that. It's kind of close. I think they're going to be short on profit. It's right about here. I want to test that out. So let's go back to these equations and plug that point in and see what. So if they do 4 times the number of student tickets, which are sold for, or sorry, it's $4 each, right? 475 of this. So $4 a piece for 475 plus, and then it was $7 per adult ticket. So it'd be 7 times, and then they said 200 of those. 200 of those. Okay. Now, just eyeballing my graph, I was thinking it's going to be a little short of their profit goal, right? Which was 3,400. They need maybe their revenue sort of that needs to be $3,400. Is it? Yeah, it is. It is. It's just short. 3,300. 3,300. So in fact, this point does not work, right? Because now they do have enough seats, right? There's plenty of seats. They got more seats that could sell more tickets, but yeah, they're a little short of their fundraising goal. Right, so no, it doesn't work. Mm. Next, all right, let's do 2 more. And so number 20, write a system of inequalities for the graph shown. Okay, so this is just backwards what we've been doing. But we didn't take equations to make the graphs. Now we're going to give us a graph and make the equation. We can do that. Number 20. All right, so this right here. So we're honing in on this triangle. Well, 2 of these are just straight line. There's one horizontal, one vertical line. Let's knock those out first. So it's like y has to be above or equal to -2. So y is greater than or equal to -2. There's no x because it's just a flat horizontal line. X could be anything. And then what about this vertical one? Well, that's like an x type equation. And it could be to the right of that, or it has to be to the right of that. So x has to be greater than or equal to, this looks like -3. Is that its coordinate? Okay. And so there's the horizontal line, there's the vertical line, and then there's this diagonal. Now that has a slope of -1 and an intercept at 3. And it has to be less than or equal to that. So say y is less than or equal to the negative x plus 3. I think that should be the answer right there. So this should be my system right here. That should do it. All right. Okay. I'm going to take a test point and just guarantee that does work. So it looks like 0, 0 could be a valid point. Right? That could be uh, they were calling that well, okay, within the feasible region, right? A viable point. So 0, 0. Is 0 greater than -2? Yes, it is. Bing. Is 0 greater than -3? Yes, it is. Bing. And if this is 0 and 0, is 0 less than or equal to 3? Yes, it is. Bing. So this test point 0, 0 does pass all three of these. Yeah, so that's definitely the system. All right, last one, number 21. This is a good challenge question right here. 21. 21. Okay. So it says find the area of the region defined by the following inequalities. And so they give us four inequalities. We got y is greater than or equal to -4x minus 16. We got 4y is less than or equal to 26 minus x. Can I call it -x plus 26? Same thing. Okay. We got 3y plus 6x is less than or equal to 30. And we got 4y minus 2x is greater than or equal to -10. Okay. All right, so that's pretty much copy, shape of the book. So there's my system. Now these look like all standard form. Well, except for the top one, that look, well, okay. Actually, I'll put this all in slope intercept, and the top one's already ready to go. So that's just y is greater than or equal to -4x minus 16. I'll just keep that. Okay. This one, if I divide both sides by 4, I'm getting y is less than or equal to -1/4 x plus, okay, 26 divided by 2 is 13, divided by 2 is 13 over 2, right? Or 6.5 if you like. 13 over 2 equals 6.5. Maybe I'll hold on to that idea. Okay. This one, if I subtract over 6x and then divide both sides by 3, I'm getting y is less than or equal to 6 over 3. It'd be -2x and then plus the 30 over 3 would be 10. And then see, double check, sure, yeah, okay. This last one, if I add over the 2x and then divide both sides by 4, getting y, okay, greater than or equal to, okay, 2x over 4, that'd be 1/2 x. Then minus 10 over 4, that's minus 5 over 2, it reduces to, right? 5 over 2, by the way, is equal to 2.5, or if I keep the negative, okay. And so there's my same system in slope intercept form. And so I can use that to make a graph. Graph per se. Okay. Well, okay, I only got so much space here. Here, let me bump this book out of the way, Dave. Okay, so I don't know if I can fit my equations and my graph simultaneously, and it's kind of a tight fit. Do my best here. Because I'd like to make this fairly big. Let's see how to do that here. So this one I have worked out ahead of time because this was a little tricky. So the x-axis, y-axis, I'll take this to 5 right here. It's going to be -5. This can go 5, 10, right? And then go -5, -10. Okay, so there we go. Right? Okay, so one at a time. I got -4x minus 16. Oh, okay, actually, it goes um, here. Here, I'm going to show you guys the work I did ahead of time. Right, so this is what it ends up looking like. And so if I go down to -16, it's like way down here. But the region that's bounded actually ends up being like closer to the origin. So that's why I just graph this part so I can blow this up and look at this. It's like where does this sort of cross this axis right here? This might be what I want to know. Smooth out. Okay, so it does go through the point -3, -4. That's going to be 1/4. I can show you guys that's true. So if I plug in -3 for x, -4 times -3 is +12. 12 minus 16 is -4. That's that point right there. Okay. So I'm sort of working back from knowing what the answer is going to be. Okay. So negative, say, -3, okay. -4, that's like right here. Okay. So that's -3 comma -4. That's one of my points. Okay. This also is going to go to the point -4 is 0, right? This line right here. That's what I'm looking at. I can show you that's also true. If I plug in uh, -4 for x, -4 is positive 16 minus 16 is 0. Yeah, so it goes through right here. Okay. And I need y to be greater than or equal to that. So this line's going to go sort of this way. Zip. And the y-intercept is actually off the page, but it's way down here, -16. Okay. So anything above that, it's like this region right here. Right. So we got one condition down. Like x1 -1/4 x plus 6.5. So here's 5, 6, 7, 8, 9, 10. 6.5 is right here. Okay. And then down 1/4. So here, I'm looking at this line right here, this line right here. Okay. Which again, having worked this out ahead of time, so save you guys a little time, but you guys can test this if you want. Does cross my original line that I already drew at the point -6, 8. So I'm gonna put that on the board. So -6, 8 is right here. That's this point. So this is -6, 8. Okay. This line crosses through right here. Sure. Just like that. Yeah. All right. Then oh, it also, by the way, does happen to cross through 2, 6, which is going to be important later. Okay. So let's see, 1, 2, 3, 4. So 2, 6, that's right here. This is the point 2, 6. So hold on to that idea. Okay. All right. Next inequality, so it has to be less than or equal to that. So anything down here. So already we're narrowing down to this space here. Above this line, below this line, wait for the switch. Third one, -2x plus 10. Here's my plus 10. And then -2x would bring me down to this 5 right here. And yeah, it should cross right through. No, okay. Not exactly at scale. Here should be point 2, 6. Right, it does go through that also. You can, again, test that out too, but it will be that. Okay. Goes through this 5 right here. Uh, would be the point 5, 0. 5, 0. Okay. And I think it should be less than that, right? It should, yeah, less than or equal to. Okay. I'm making these all solid lines because they're all potentially equal to. And this last one, say 1/2 x minus 5 halves. So -5 halves, it's going to be 2/2. Well, it's halfway to. I should scale this a little better. Okay, you guys get the idea. So maybe 2.5, like halfway to this 95. Um, okay, 1/2 slope. Right? Now, again, since I worked this out ahead of time, this line also crosses through 5, 0, -3, -4. And so, yeah, pretty close, pretty close. Right? Oink. That's it. Right? And it should be, let me just double check, should be above that, I think. Yeah, there it is. Greater than or equal to. Yeah, so we're good. So this is what this looks like, the shape. So we've got these points at 2, 6, -6, 8. Yeah, -3, -4, and we have 5, 0. This is my 4 points. Okay. Okay. The region in question is this whole quadrilateral looking shape right here. Okay. So the question is, what is the area of that region I just shaded in? Okay. So there's different ways to solve this. One thing you can do is split this into a bunch of little triangles. Okay. Where I would need like a base and a height. Now, the way I did this before, and I got the right answer because I checked the teacher's manual, so yeah, okay, this does come with the 75 units in the end, is I split it up this way. I said, well, it'd be, because you guys know what the area of a triangle is, it's 1/2 base height. So I'm looking at 3 triangles. So I see this triangle down here, right, with some base, some height, so 1/2 base height. I see this triangle right here, some base, some height, so 1/2 base height. And then there's this sort of like turn triangle, which is going to be kind of tricky, but I'll address that one later. Okay. So maybe I'll call these like area A could be this triangle right here. Area B could be this triangle right here. B for blue, so that. Okay. And then I'll come back around to this area. I'll call this area C is this weird looking triangle up here. So we'll do that one last. So, right, new paper, so I can add up these areas. And so You guys know area of triangle equals 1/2 base height. So I can play off that. So area A would be 1/2 of, this has a base of, see, it goes from, this is the point, uh, -4, comma 0. So -4 to +5, that'd be a base of 9. This has a height, like this altitude right here, of 4 units, as it goes to a -4 here. So 4. Okay. Well, half of 4 is 2, times 9 is 18. So it should be 18, um, I'll say square units. Okay. Whatever these units are. If these are meters, this would be square meters, inches, square inches. Okay. So I have one area is 18 of this. Okay. That's this area A right here. Okay. How about this area B? Now it has the same base. So the area of section B, so 1/2 base height, because it's also a triangle, the base is the same. It goes from -4 to 5. That's 5 minus -4 is 9, like just like it was before. And this is a height of, well, what's the height of this altitude right here? Well, it goes up to 6. It goes up to 6 here. So it has a height of 6. Okay. Half of 6 is 3, times 9 is 27. So that's 27 square units and square meters, square inches, whatever that may be. And now this triangle C is tricky, but I was thinking ahead of time, I wonder if I could find like this width and this height and do 1/2 base height, because none of these three sides are aligned with the X or Y axis. Okay? You can't actually do it that way though, because it overestimates the area. Okay? One way you can do this is you can introduce a square. You guys notice this goes from -6 to +2 could be 8 units wide, and then it's also 8 units tall. So I can overlay an 8 by 8 square. Guess this nice 8 by 8 square, and it can subtract out everything except for this triangle. Okay, so I really want to know this area C, which is this triangle right here. Okay, so area C could be the same thing as, I could go an 8 by 8 square. So that's definitely way more than it actually is. And then start subtracting off uh, this triangle, right? This triangle, and this little skinny triangle up here. And so let's do those one time. Right, so minus 1/2 base height. Now this has a base of 2, it looks like, and a height of 8. Right? This triangle here, look at this one right here, has a base of, see, it goes from, I think for two, 6, I think that's 6, right? 155, 6, and a height of also 6. So minus 1/2 base height on that front. Okay. And then this little skinny triangle up here has a base of 8 and a height of, let's see, is that 2? Yeah, from 6 to 8 would be a height of 2. Okay. So minus 1/2 base height like that. Okay. Woo! Right. So that's equal to, well, this first bit's 64. This is 8. This is, let's see, half of 6 is 3 times 6 is 18. All right, then this would be another 8. All right, so make sure, yeah, okay, so take my work from before, that's the same thing I got before, just something about like that. So we're on the right track. Let's do 64 minus 8 minus 18 minus, oops, sorry, these are minus 18 minus 8. Comes out to 30 square units. Square units. Okay. Woo! All right. Okay, so I have these three areas, A, B, and C. Okay, so if I add those up, so A plus B plus C would equal that middle region, 18 plus 27 plus 30. Yeah, is 75 square units. And that is the textbook answer. So I did double check that one. Okay. All right, there we go. So ending on a challenge there. Here's the answer, and then go back to this graph picture.